you. Okay, hi guys. So, if you're a senior, this is important, listen up please. Capping down forms are due a week earlier due to a district deadline that was moved up. New Herb Jones capping down package for $50 can be purchased online at www.hjgradstuff.com or wait until the representative comes on campus at the end of March. All seniors must return the form to D219 or the senior student mailbox in the main office by March 13th. Blank forms are available in D219 if you need another one. Does anyone have their form right now?
Yeah.
Okay, you guys can pass them up. And then, do you guys have any questions on that?
What's the due deadline?
March 13th. And if you guys can't afford to buy one instead of rent one, make sure you buy it because if you're renting it, there's a new district law where the whole district votes on a color. So you guys can be getting like blue or green, any random color they put. What?
You're getting black if you don't buy it. If you buy it, then you're getting what color?
They don't know what
It's
color
not
yet.
for sure black. It's probably going to be black, but we don't know.
Yeah, it could be any color. They're voting on the cheapest one, so you don't know what color you're getting. And then for the attendance violation notification, any student on the attendance violation will receive a printout of their uncleared absences within the next 3 days. You have until March 13th to bring in appropriate documentation to clear your absences. Only absences for school activities, illness by a doctor's note, campus tours, or scheduling errors will be cleared. If you do not clear your absences by the deadline, you will remain ineligible to participate in all future senior events for the remainder of the semester. Any questions? Thank you.
Thank you.
Okay, so we are looking at gender differences and student needs and fears. Random samples of male and female students were selected from those attending a particular university. Of the 234 males surveyed, 27.4 said they were concerned about the possibility of getting AIDS. Of the 568 females surveyed, 42.7 reported being concerned about the possibility of getting AIDS. Okay, so what are we trying to show? Is there sufficient evidence to conclude that the proportion of female students concerned about the possibility of AIDS, getting AIDS, is greater than the corresponding proportion for males? Okay, so we just want to know if one proportion is bigger than the other proportion. So that tells me that it's a hypothesis test. So we're trying to see if one proportion is greater than the other. There's actually something we want to figure out. We're not just trying to estimate, we're trying to figure something out. So that means we should use a hypothesis test. And the problem says proportion all over it. So this really should be a hypothesis test for a proportion. Okay, before we can get into the first 5 steps, a good thing to think about is what were the results of the survey? How many people said, how many males were concerned about AIDS?
64.11 to 64.
And how do we get that number?
By multiplying N1 times the percentage.
Sure. So it's 27.4 of 234 were concerned. How many males is that? That's 64.166 males. But remember, this is an actual survey that happened. They didn't serve, 0.116 of a male didn't actually say, hi, I'm concerned about getting AIDS. It was either 64 males said yes, or 65.
So how do they get the number 27.4?
By rounding, most likely. Okay. So we have 64 males. It's not about 64 males. 64 males had to have said yes. 64 out of 234 were concerned. Just do a real quick check. Notice that that is 0.2735, which rounds to 0.274. So that's how come it was reported as 0.274, that rounding issue. Is everyone okay with that? We just found out how many males were concerned. How many females were concerned? Let's see, 42.7% of 568. That gives us that number. How many females were concerned? 243. 243 out of 568 females were concerned. Let's do a real quick check. What number do we get if we make that division? 427. 4278. Close. Okay. So that's a good thing to start off with. Find out exactly what the results of the survey are. You're going to need those numbers. Step one, let's get our populations down. Okay, we're talking about the population, so we need to use pi. Which proportion do you want to use for pi 1?
Hi,
the males?
sorry to interrupt. Do you have plastic gloves? I have a bleeder.
I don't. I might. Yeah, I do.
Awesome. Thanks. Wow, you hooked it up. All right, thanks.
No, I didn't look at her footwear. Happens. Okay, pi 1. Which proportion is this? Males or females?
Females.
You want females?
Yeah.
Okay. Proportion of females concerned about getting AIDS. Okay. Pi 2. Yeah. And I really wish you could just copy and paste. Yes. That's fine. Yeah. You can just quote it up. That's fine.
So we could just write proportion of males and then quote the concerned about AIDS.
Yeah. That's fine. I think they would take that on the AP test, yeah.
If they understand we're like under time pressure.
Yeah. They know you're under time pressure. As long as you don't skimp out on the really important parts. Okay. Okay, so that takes us through step 1. Let's look at step 2. Step 2, of course, are the hypotheses. We need a null hypothesis. That's pretty clear. It's almost always going to be pi 1 minus pi 2 equals 0. That should be minus. And the alternative hypothesis, which one's supposed to be greater, the females or the males? Females, okay. And females is pi 1. So if we have a greater number minus a lesser number, is that result going to be positive or negative? Should be positive, greater than 0.
Are we just trying to see if there's a difference between the two?
No, I think it said, are there more females concerned than, yeah. Yeah.
You said the null hypothesis is almost always pi 1 minus pi 2? When would
Equals
it
0.
equals 0?
Yeah, it's always going to be pi 1 minus pi 2. But it's equal to 0 is the part that I mean almost always. Okay. Always do a check to make sure pi 1 minus pi 2 greater than 0. That simplifies to pi 1 is greater than pi 2. Is that what we want to say? Pi 1 is greater than pi 2? Yeah, it is. It is. All right, step 3. This is everything about our confidence or our sampling distribution. So, first thing about our sampling distribution, where is the center?
Mu pi 1 minus pi 2. It's good to write pi 1 minus pi 2, right?
Yeah, if you wrote pi 1 minus pi 2, that's a minor error. I wouldn't be concerned about it.
Like no points off.
Yeah, no one's gonna.
Because I always do that. I'm used to it now.
All right, so this is 0 from the null hypothesis, right? That's been a pattern all the way through here, so that shouldn't be a surprise. All right, we have to compute sigma. So we're going to need PC. Yeah, PC. PC is the total number of successes divided by the total number. So how many people said yes? Yeah. 64 males, 243 females. That's 64 plus 243. Divided by, how many people were in our survey? 234 and 568, right? Yeah, 3828. That's my PC. If you'd like to streamline your work, you might want to figure out 1 minus PC right now. That's a good thing. That's 1 minus 0.3828. Okay. And if you'd like to further streamline your work, okay, you don't have to do this, but you might want to do PC times 1 minus PC. Really? Alright, so that's P1, PC times 1 minus PC. That's a good thing for you to have. You're going to be using that for sigma P1 minus P2. So let's get sigma P1 minus P2. That's going to be the square root of PC 1 minus PC, which we know is 0.2363, divided by the first sample of 234, plus 0.2363 divided by the second sample, 568. And that looks a lot nicer when you multiply PC and 1 minus PC, isn't it? Oh, jeez. 3778, 378, 0378. That's great. Okay, and step 3, we need to check our conditions. What's N1 times P1? 234? 243.
Yeah.
Which is greater than 10. N1 times 1 minus P1? 325. Which is also greater than 10. N2 times P2?
64.
That's 64, which is greater than 10. N2 times 1 minus P2?
160. 170.
170? Yeah. That's greater than 10. So everything is greater than 10. The correct conclusion here should be normal procedures are safe. Do you have to write normal procedures are safe? Yes, you have to write that. Okay, that's not an option. Assume normal what?
We also have to state if it's random or not, right?
Yes.
Would you say it is independent just because it's males and females?
Yeah, there's no person who's in both samples, so the two samples are independent of each other. Okay, so random samples. So samples are, quote, random, right? Did this use a phrase randomly selected?
You said random samples of male and female students we selected.
Random samples. And since no person is in both samples, they are independently selected. Independently selected? No.
Doesn't matter. No other matter.
Do we have to
Yeah,
tell why
you
it's
just missed that.
independently selected? I expect it's independent.
You should have some indication why. That brings us to the last one, or step 4, which is the easy one, right? Our calculations. Z star is going to be equal to P1 minus P2. What was P1? 0.274? Minus 0.427 minus 0. All that on the numerator. Divided by our sigma P1 minus P2, which is 0.0378. Yeah, that gives us a, wait, did I get these in the right order? I don't think I got these in the right order. Well, that's better. That'll give me a positive result, right? Cool. 4.04748. I'm going to use 4.05. No, 4.05, yeah. Lastly, that p-value is going to be equal to the probability that z is greater than 4.05, and that's about 0. Any questions on why that's about 0? We all kind of figured that out. That's good. Last step. Let's get a nice conclusion here. Okay. We're going to reject or fail to reject our null hypothesis. Good. Since the p-value is less than alpha, zero is less than 0.05, we reject the null hypothesis. I don't know why I did that. I could just use H0. If the null hypothesis is correct, is true, the probability of obtaining the sample is about 0%. Since this is unlikely, we have to conclude about the alternative hypothesis. The alternative hypothesis says that the proportion of females concerned about getting AIDS is greater than the proportion of males.
So it's mentioned students, or it doesn't matter?
Yeah, we should be saying students. Female students.
Will we get points off on a test if we didn't see students?
I think it's pretty well implied here. Yeah.
What if instead of saying we conclude, I wrote like we can assume?
I wouldn't say assume, because you're not assuming anything.
Okay.
You're concluding something. Do you have ribs?
Yeah.
Nice.
So, you want?
It's extra fancy.
What?
Okay, anything we can clarify with part A?
Can you go back now?
Sure.
Mr. Ferdinand,
Mhm.
I think I'm gonna
Okay, have a good race.
this is gonna be the test gonna be on proportions
And confidence intervals. Proportions and means, yeah. Proportions means confidence intervals and
for difference in means standard deviation is or standard error is equal to
standard error would be equal to sigma of,
sigma
of
sigma
the
1
differences.
squared over sigma 1 squared over n and sigma 2 squared over n.
That's for two samples, not for, yeah, for two samples.
For talking about difference.
Yeah, yeah.
Can you go to the restroom?
Okay, and I think, I don't know, do we have enough time for the last one?
It's 2:22.
It's 2:22.
12:22. We have 10 minutes.
Okay, should we push it or are we done? Okay.